Okay, Assalamualaikum and good day to everyone. So my name is Nabila binti Rahim and my supervisor is Dr. Nurmiza binti Osman, and my title for PSM is IoT based heat stroke early symptom monitoring system for primary school students in Malaysia. So in this presentation, I will explain about my introduction, literature review, methodology, results and conclusion. So for the introduction part, as we all know that Malaysia is a Southeast Asia country that located at equator line, and the temperature is fluctuating between 25 to 35 degrees Celsius all the year. So due to the hot temperature and high level of humidity in Asia, heat-related illness commonly happen, and one of the examples is heat stroke. So first, for my background study, so heat stroke occurs when human body can no longer control the body temperature. A person can have permanent disability of organ or death. Relative humidity of surrounding also play important part in heat stroke. High relative humidity, if combined with hot weather, makes human body dehydrated faster. Thermometer and pulse oximetry are two medical instruments that can be used to measure body temperature, blood oxygen level, and heart rate of a human. So next, for the problem statement. So when I do my research, so I knew that the schools in Malaysia does not provide continuous monitoring device. And available devices such as smartwatch are too expensive and not affordable to students. As for smartwatch, it needs the presence of mobile data to watch the data. And parents cannot monitor their children's condition regularly. And next one is the available marketed device targeted only on industry company. Also, the other one is high cost of high advanced device such as temperature device. And lastly, health monitoring device for students are available but only in China. So next, the objective for my project is one, is to develop an IoT-based early detection system on heat stroke symptom. The second is to design a website application and database on MySQL for continuous monitoring the data obtained from the sensor used in the circuit. And lastly, to provide the data to the authorities for further analysis. Next is my scope of studies. So Arduino IDE will be used to upload the code to the microcontroller board. The threshold value for normal reading is being set for each sensor. Website application will be used to monitor the status of the student in the school. And then the sensor used in this project is pulse sensor, oximeter, and temperature sensor. Lastly, the data for this project will be gathered from the primary school students in Malaysia. Next is for the literature review. So this is the available devices at the research level or in the market. So in 2018, these devices is made by Sheng Tao Chen and other researchers, and it is available at research level for athletes. So it is equipped with MLX 9614 sensor for the body temperature, SHT75 environmental sensor, Groove GSR for skin resistant, and heart rate sensor. Next, in 2021, these devices is made by K-Manasa and available at research level for patients at home, especially the elders. It is equipped with body temperature sensor, environment temperature and humidity sensor, and lastly, blood oxygen level sensor. Also in 2021, these devices is made by Theo Wilson and another researchers, and it is available at research level for broad user. It is equipped with heart rate sensor, surrounding temperature and humidity sensor, and body temperature. In 2022, this is the devices that is available at market and targeted for industrial worker. It is made by Kanzen company. It is equipped with heart rate sensor, core body temperature sensor, skin temperature, and sweat level detector. And lastly, in 2023, These devices is made by Muhammad Ahmad Bitar and Dr. V. Sujata. It is available at research level for broad user, and it is equipped with temperature sensor, heart rate sensor, and DHT11 sensor. And these devices also uses tiny ML and machine learning technology in the devices. Okay, next is for the methodology part. So this is my block diagram for the project. So I use ESP32 board, and then it will be supplied by using 12 volt 2 ampere adapter. So the input for this project is momentary button, MLX9614 temperature sensor, max 3000 oximeter sensor, and RFID RC5222 scanner. And then the output will be the LED green and red, and then buzzer. So all the data will be connected to the website application, and the database can be viewed through laptop or mobile phones. So this is the flowchart of my project. So it will start by initializing the system, connecting board to the Wi-Fi, and connected to the web application. So first, the user need to touch the card to the RFID scanner, and the system will read RFID tag. If the RFID tag is registered, it will read the beat, the heart rate, the oxygen level, and temperature sensor. If it is not registered, the admin will need to add the user ID to the website. And then after the system has read all the all the sensor parameter, if the momentary button is pressed, it will send all the data to the database and the LCD. If it is not, it will continue to read the sensor parameter. Okay, so that's all for the flowchart. So this is the hardware development. So this is my full circuit for the project. So I use ESP32 microcontroller, max 3000 sensor, MLX9614 sensor, RFID scanner, and LCD display 20x4 with I2C. So this is the full circuit for the project. So I use freezing to create this circuit. So next, so this is the full prototype of the project. So as you can see here, it is divided by two parts. So the first part at the top one consists of momentary button for sending the data to the LCD and then the database, and it also equipped by MLX9614 sensor. So the second part is the main part of the prototype. So it consists of buzzer, LCD display, RFID scanner, ESP32 board, and max 3000 sensor. So for the software development part, I use my SQL for the database and website application to view the database that has been created and the user that has been registered. Okay, so next is for the result. So this is for the hardware development. So in the left side, this is the initial display of the LCD, and then for the right side shows the system when it detects the user's card. So when the user is registered, the system will say the tag is registered. Meanwhile, if it's not, the system will say it is not registered. So if the user is registered, it will say please stand still at designated area, then press left button to send the data. So at the right side, it shows the user's hand placement to take the measurement on the sensor. And the user must stand still for about 10 seconds to make sure the sensor is calibrated and send the right value to the database and LCD display. So this is after the user have pressed the left button, so it will show the read measurement. Okay, so this is for the software development. So at the left side is the website interface to add new user and view existing user, and then for the right side is to add the new user data. And then this is the dashboard to view all the measurement data that has been taken. It will display username, identification number, sensor measurement, time and date taken for the measurement. So admin can choose to view the data from what date by choosing the start and end date at the top. So this is measurement taken on 5 people. So the data is not very correct because I intended to take the data from the primary school, but because of like the time constraint, I don't have time to take the data from the primary school. So I just test it on my friends. So this is the data measurement taken by the project prototype. So this data has already been verified by using microlife with digital temperature and then belly pulse oximeter. So and then this is the compact measurement that has been taken by the available devices on the market, that is microlife digital temperature thermometer, and then the belly pulse oximeter devices. So the error rate may be like 2.0 from the project prototypes. So this is the demo video. So you can see here.
Okay, so first for the registered user, so this card is for Alia. So we can see here, Alia is here in the database. So to take measurement, so first we need to touch the card. Okay, it will say registered. Okay, so to take the measurement, and then we need to wait for like 10 seconds. And press here, the button here. Show the measurement. Okay, and you can see at the dashboard. So this is the measurement taken.
The demo video that has been watched is for the registered user. The unregistered user video.
Okay, so for the unregistered user, we need to press this button here. Okay, and then we need to touch the RFID card to the RFID scanner. And then we'll say not registered. So we need to register it. And as we can see here in the website, it already automatically added the RFID number. Okay, so we need to just fill up. Okay, make sure to fill out all the personal data and then press add. And then change to registered. Okay, so now the new user can take measurement as usual. So just put down here and then the target is here. And then wait for 10 seconds. Okay, press this button here. Also click the sensor value. Okay, next we can see the recorded data here. So this is for the new user one. So I think that's all from me. Thank you.
So next is for the conclusion part. So in conclusion, this project has successfully met its objective, but the monitoring can only be done by an authority that has access to the database. Moreover, the projects enable the dissemination of results to relevant authorities, facilitating further analysis. Next, for the recommendation part, there are several recommendations and suggestions to improve this project. So one of it was adding GSM module to the circuit so that it can send notification to the guardians when the system detected abnormal readings. So another recommendation also may be added another interface in the website application for the parents to view only their children's data instead of all the students' data. So I think that's all from me. Thank you.